Welcome to Rockin' OTs, an indoor rock climbing activity analysis. Today we will be studying the kinesiology of rock climbing.
Rock climbing is a sport that requires simultaneous physical and mental coordination that tests a climber's strength, endurance, agility, and balance. The goal of rock climbing is to reach the end point of a predefined route, typically to promote self-achievement of a difficult activity. As a rock climber, it is imperative that one must wear the proper clothing and equipment to prevent injuries. This includes a comfortable shirt, athletic undergarments, athletic pants or shorts, socks, and lightweight athletic shoes. To ensure safety, the climber must wear a harness that attaches to the rope on the wall. The rope holds the weight of the climber as he or she goes up and down the wall.
Cognition is one's ability to consciously gather and process information for the purpose of acquiring knowledge and facilitating behavior. Cognition plays a key role in the climber's ability to safely perform the coordinated movements needed to reach the endpoint of the desired route. The climber's cognition must be intact to carry out various functions that are essential to the intricate movements of rock climbing as well as the safety of the climber. These functions include balance, coordination, attention, concentration, spatial awareness, visualization, and planning. The temporal lobe is involved in primary auditory perception, which is directly responsible for balance due to the ear canal's intact equilibrium. The posterior part of the parietal lobe is responsible for attention, focus, and spatial awareness. The occipital lobe is responsible for visualization. The frontal lobe is responsible for initiating and coordinating motor movements, higher cognitive skills, thinking, planning, and organizing. The cerebellum is responsible for balance, movement, and coordination.
The respiratory system is a series of organs responsible for taking in oxygen and expelling carbon dioxide. Oxygen and carbon dioxide are required for the body to sustain itself. Red blood cells carry oxygen from the lungs and supply parts of the body. The red blood cells also transport carbon dioxide to the lungs where exhalation occurs. The respiratory system is composed of various organs and components that lie in the thoracic cavity. The organs include the nose and nasal cavity, pharynx, larynx, trachea, bronchi, lungs, alveolar diaphragm, and heart. While rock climbing, one's breathing technique should remain smooth, controlled, and calm. 3 simple breathing tips to remember while climbing includes breathing before and after each climb, breathe at a controlled pace, and adjust breathing according to increased movements.
The cervical spine is an active component involved in the climber's ability to move the neck in various positions needed to safely plan hand and foot placements. While climbing, one must have normal range of motion for flexion, extension, and rotation of the neck. The cervical spine is comprised of 7 vertebrae, which are the C1 through C7. The vertebrae protect the brainstem and spinal cord, support the skull, and allows a wide range of head movement. The cervical plexus is a plexus of the anterior rami that supply innervation to some of the structures within the neck and trunk. It is composed of axons from spinal nerves C1 through C5 and branches into nerves in the posterior neck and head, as well as the phrenic nerve, which connects to the diaphragm at the base of the thoracic cavity. In neck flexion, the climber's cervical spine should fall between a range of 0 to 45 degrees to be within functional limits. The muscles involved in cervical flexion include the sternocleidomastoid, anterior scalene, longus capitis, and longus coli. As the climber strategizes their following foot placement, these muscles are being used while looking downward to properly gauge safe positioning. This action is an example of contrinsic contractions. In extension, normal range of motion lies between 0 to 45 degrees to be within functional limits. The muscles working include the trapezius, elevator scapula, splenius capitis, splenius cervicis, rectus capitis, posterior major and minor, oblique capitis superior, semispinalis capitis, longissimus capitis, longissimus cervicis, iliocostalis cervicis, multifidi, rotorors, intertransversi, and the interspinalis. As the climber reaches new heights, these muscles are used to aid the cervical spine in planning of hand placement. When extending the neck, the climber is elongating the muscles, performing eccentric contraction. The normal range of motion for rotation lies between 0 to 60 degrees. While rotating the head side to side, the climber can properly sequence hand and foot coordination. The muscles used in cervical rotation include the levator scapula, splenius capitis, splenius cervicis, rectus capitis, posterior major, oblique capitis inferior, longus colli, longus capitis, longissimus capitis, longissimus cervicis, and iliocostalis cervicis. All of these muscles stimulate eccentric contraction.
The shoulder is the most mobile joint in our body. To avoid uneven tension around the shoulder joint, balance muscles are essential for climbing. The muscles of the arm consist of wrist and elbow flexors and extensors. Within these muscles are nerves that innervate them, which are the musculocutaneous, axillary, median, ulnar, and radial nerves, all of which make up the brachial plexus. The brachial plexus is a network of nerves formed by the ventral rami of the lower four cervical nerves and first thoracic nerve. Its function is to send signals from the spinal cord to the shoulder, arm, wrist, and hand. The brachial plexus is responsible for each functional movement in the arm that the climber would need to place the arm in the next desired position. The biceps brachii, coracobrachialis, and brachialis muscles are innervated by the musculocutaneous nerve. These muscles function in flexing the elbow and shoulder. The triceps brachii is innervated by the radial nerve and aids the climber in elbow extension. The deltoid is a large, strong muscle responsible for flexing the shoulder and immediately rotating the humerus as the climber reaches for the next rock.
During the climber must have normal function of the wrist, hands, and digits, which include flexion, extension, adduction, and abduction. Its structures include the digits, proximal, middle, and distal phalanges, metacarpals, and 8 carpal bones. These bones meet together to promote movement and stability via the joints. When climbing, flexing the wrist requires the flexi carpi ulnaris, flexi digitorum superficialis, flexor carpi radialis, flexor digitorum profundus, and flexi pollicis longus muscles. Extending the wrist utilizes the extensor carpi radialis brevis, extensor digitorum, extensor digiti minimi, and extensor carpi ulnaris muscles. Abduction requires the flexor carpi radialis, extensor carpi radialis longus, extensor carpi radialis brevis, and abductor pollicis longus muscles. Adduction requires the flexor carpi ulnaris and extensor carpi ulnaris.
The hip is a major component that is needed to successfully and safely reach the end goal of this activity. The hip is a ball and socket synovial joint, the ball being the femoral head and the socket the acetabulum. The pelvis is the foundation of stabilization. It helps the body maintain a normal lumbar curve. The hip joint is the articulation of the pelvis with the femur. The 3 bones that make up the pelvis include the ilium at the rear, the ischium at the lower front, and the pubis above it. External rotation of the hip is used to make alternating movements of the lower extremities, while the climber bears weight on the leg that is fixed on the rock. The muscles used in external rotation of the hip includes the gluteus maximus, the piriformis, the quadratus femoris, the abductor internus, the abductor externus, the gemellus superior, the gemellus inferior, the gluteus medius, piscis major, the iliacs, the sartorius, and the biceps femoris. While rock climbing, the climber uses hip flexion to assist the body to move along the wall. The normal range of motion of flexion of the hip is 0 to 120. For the climber to complete this motion, the climber must utilize the piscis major, the iliacus, the tensor fasciae lati, the sartorius, the rectus femoris, the gluteus medius, the gluteus minimus, the adductor longus, pectinis, adductor brevis, and the adductor magus. When moving from one rock to another, the knee is extended and the ankle is plantar flexed as the climber pushes downward on the rock to scale along the wall. The knee is flexed and the ankle is dorsiflexed each time the climber steps onto a new rock in effort to reach the new altitudes along the path.
Thank you for watching Rockin' OTs, an indoor rock climbing activity analysis. See you next time.